Welcome back, students. Let's wrap up our work on logarithms for the day with these 5 examples. This one looks kind of strange. The base is a fraction. Log base 1/2 of 4 is equal to what? What exponent changes 1/2 into 4? Well, I know when I've got fractions, I'm generally thinking negative exponents. Let's see why. We'll set this equal to x. Then x is the exponent that changes 1/2 into 4. What exponent changes 1/2 into 4? Let's try a little scrap work. Here are some things I know. I know that 1/2 times 1/2 is 1/4. Look, I got my 4. 1/2 times 1/2 is the same as 1/2 squared equals 1/4. But I don't want 1/4. I want 4. Now 4 is the reciprocal of 1/4. How do I get a reciprocal? I get a reciprocal by using a negative exponent. 1/2 to the negative 2 power is equal to 4. Because if I take 1/2 and flip it, reciprocal, and square it, reciprocal is 2, and 2 squared is 4. 1/2 to the negative 2 power is equal to 4. So what exponent changes 1/2 into 4? It must be negative 2. Log base 1/2 of 4 is negative 2. Because if I use that as an exponent, 1/2 reciprocal and squared gives me 4. Let's try that again. Again now, I have a fraction as my base. So I'm expecting my answer to be negative so that I get a reciprocal. 4 times 4 times 4 is 64. 1/4 time, well, that's got to be a negative 3, I think. Let's check it. Let that be x. Then 1/4 raised to the x power must give me 64. Let's think this through. 1/4 times 1/4 times 1/4. 4 times 4 times 4 is 64. That is 1/4, 1, 2, 3 times to the 3rd power is 1 over 64. But I don't want 1 over 64. I want 64, which is the reciprocal of 1 over 64. What kind of an exponent gives me a reciprocal is a negative exponent. 1/4 to the negative 3rd, that's 64. What exponent changes 1/4 into 64? That must be negative 3. Log base 1/4 of 64 is negative 3. Because if I take 1/4 and reciprocal and cube it, I get 64. This one's extra difficult. Now, if I was going to try to do it in my head, here's what I would be looking at. Log base 3/2 is 4/9. What happens if I square that 2? I get 4. What happens if I square that 3? I get 9. So my answer is going to be 2, except the 2 is in the bottom and the 4 is in the top. The 3 is in the top and the 9 is in the bottom. That's upside down. That's reciprocal. I'm thinking negative 2. Let's work it out. What exponent changes 3/2 into 4/9? If I square the 2, I get 4. If I square the 3, I get 9. But this is upside down, so it's got to be a negative 2. Let's see if we can make that look right on scrap work. 3/2 times 3/2 is 9/4. Do you see that the 9/4 is upside down? 3/2 times 3/2 is 3/2 squared. That's 9/4. But instead of 9/4, I want the reciprocal. What kind of an exponent gets me a reciprocal is a negative exponent. So what exponent changes 3/2 into 4/9? -2. What exponent changes 3/2 into 4/9? -2. So final answer, log base 3/2 of 4/9 is -2. Here's the last type of logarithm problem. Again, kind of strange. For the first time, my base is really large, while this number is much smaller. Let's work it out this way. What exponent changes 49 into 7? Well, remember back here where we had what exponent changes 16 into 4? That's a square root. What exponent changes 27 into 3? That was a cube root. What exponent changes 49 into 7? Think of it this way. The square root of 49 is 7. Another way of showing square roots is as 1/2 powers. What exponent changes 49 into 7 is 1/2. What exponent changes 49 into 7 is 1/2. Final answer, log base 49 of 7 is 1/2 because the square root of 49 is 7. Let's see if we've got the pattern. What exponent changes 36 into 6? Well, must be 1/2 because 1/2 as an exponent means square root, and the square root of 36 is 6. The square root of 36 is 6. Another way of writing square root is as 1/2 power. So what exponent changes 36 into 6 is 1/2. What exponent changes 36 into 6 is 1/2. All right, you go try some problems on your own now. This will wrap up part 1.